Allocate minimum pages is a classic optimization problem and a frequent benchmark in technical interviews at companies like Amazon and Google. Consider 4 books, 10, 20, 30, and 40 pages, and 2 students. 3 rules apply. First, each student receives at least 1 book. Second, allocations must be contiguous. Grouping 10 and 20 works, but skipping 20 is invalid. Finally, all books must be allocated. Our objective is to find the specific arrangement that minimizes the maximum number of pages given to any single student. We want to find the smallest possible maximum. Testing every possible way to place dividers between these books leads to a combinatorial explosion. On a large array, a brute force search will inevitably trigger a time limit exceeded error. Instead, we can solve this by using a technique called binary search on answer. Rather than trying to calculate the dividers directly, we pick a hypothetical maximum page limit and check if that limit is possible to achieve. If we can build an efficient way to validate a single guess, we can use binary search to narrow down the range of possible answers until we find the absolute lowest one that works. To start our search, we need to define our boundaries. What is the absolute lowest possible value our answer could be? Even if we had 1 student for every book, the student assigned the largest book would still have to read 40 pages. So our lower bound, the low pointer, is the maximum value in the array, 40. And what is the highest possible limit? If there is only 1 student, they have to read every single book. Adding these up gives us 100, which becomes our upper bound, or high. This creates a sorted range from 40 to 100. We know our optimal answer must exist somewhere on this line. Now we apply a greedy validation. Let's test a midpoint of 70. We will keep assigning books to a student until adding the next book would push them over that 70-page limit. Student 1 takes the 10, the 20, and the 30. That is a total of 60 pages. We stop there because adding the 40-page book would bring them to 100, which is higher than our 70-page limit. We assign the final 40-page book to student 2. This distribution requires only 2 students. Since 2 students fits within our limit of k equals 2, a maximum of 70 pages is a valid solution. Because 70 is valid, we check if an even smaller number might also work. We move our high pointer down to mid-1, which is 69. Let's look at a new test where the midpoint is 55. Student 1 takes the 10 and the 20 for a total of 30. The next book is 30, which would put student 1 over 55, so that book goes to student 2. Finally, student 3 has to take the 40-page book. We now need 3 students to keep everyone under 55 pages, but we only have 2 students available. This means a limit of 55 is impossible. To find a valid range, we must increase the limit by moving our low pointer to mid+1. Now try it yourself. Pause here and run the greedy check for a limit of 47. Is it valid for 2 students, and which way should the pointers move? Tracing the logic, student 1 gets 30, student 2 gets 30, and student 3 gets 40. That requires 3 students, which is invalid. We move the low pointer up. Following this process to the end leads us to the optimal answer of 60. In code, the isValid helper function iterates through the array, incrementing the student count when the page limit is breached. The main binary search loop then uses this result to adjust the low and high pointers, exactly like our dry run. A quick edge case: if students outnumber books, return -1. Performance-wise, binary search takes log of the search range, and each step iterates through n books. This gives a time complexity of O of n times log of the sum minus the max. Since we only use a few integer variables for our pointers and sums, the space complexity is a highly efficient O of 1. Here is your takeaway. Whenever an interviewer asks you to minimize the maximum or maximize the minimum over a contiguous set, think of binary search on answer first. This strategy works because the problem is monotonic. If a limit of 60 pages works, then any limit higher than 60 is also guaranteed to work. Master this pattern, and you can apply it to dozens of similar variations. Like, subscribe, and check the description for the full source code.